So how does the cochlea actually encode the intensity of the sound? That is, the strength of those pressure waves. The difference between the maximal compression of air, right, that's caused by something vibrating out here in the environment, and the maximum sort of rarefaction of the air, right? The greater that difference in pressure, the greater the intensity or amplitude of the wave, and that's going to lead to perception of a louder sound. So how is that encoded, at the level of the cochlea? Well, it's encoded by both what we call a population code, right? Because more of these hair cells are going to be displaced. There's going to be like a larger portion of the basilar membrane moving in response to higher amplitude sounds, right? If there's a greater difference in pressure, more of the membrane is going to actually move in response. So more hair cells are displaced by a larger amplitude wave, and thus more will fire action potentials, right? But there's also a second aspect. There's also a frequency code, because those displaced hair cells, by the higher amplitude wave, are going to actually move back and forth faster. They're going to get shaken more dramatically, and that will lead to much faster frequency of action potentials from the cells that do move. So intensity, sound wave amplitude, is encoded in two ways. A population code, i.e. a more intense sound moves more of the basilar membrane, right, activating a larger population of inner hair cells. And two, a frequency code, since higher amplitude waves move individual hair cells back and forth faster, increasing the frequency of action potentials. So those are two contributors to our ability to detect differences in the intensity or amplitude of the sound wave.